Hello, welcome. Today I'm going to be showing you how to build agentic AI applications with Node.js using LangChain. First, you can find all of the learning resources and the demo I will be showing you today using either this QR code or going to that URL that you see on the screen. This is a pre-recorded session, but if you have any question, you can find me in my social networks and I will be more than happy to answer. My name is Julián Duque. I'm the principal developer advocate for Heroku, and I'm super happy to be here at the Node.js Global Summit AI edition. Okay, let's start. What it is an AI application? Well, an AI application uses a large language model, or LLM, to generate or process content. They run inference across different modalities. So you can interact with these applications either with text, it could be code, audio, video. Also, these applications integrate with tools, data, user input, other APIs, etc. For the purposes of this session, we are going to be considering the term AI just for generative AI application. The term AI might be too broad, so I just want to keep it on generative AI. Okay, some of the core concepts that they are good and important to know before we go deep into the code. First, what is a large language model? Well, a large language model is a type of artificial intelligence model that is trained on massive amount of text data, and it's used to understand and generate human-like language or natural processing language. Basically, it's great at auto-completing text based off a variety of an amount of data that it has been trained on. There are like two concepts that we need to take into account. One is inference and the other one is training. Well, inference is using all of this trained data that it's in the model to make predictions, like pretty much auto-completing. Training is the process of teaching that model with existing data. There is another concept that we might see in certain models that are published online, which is the model size or the amount of parameters this model has been trained on. You might have seen there are like certain models that have the 7B or 13B or 70V. This is in billions of parameters that the model has been trained on. The larger it means that it might have better performance, but will be more slower and also more expensive. There is also another very important concept, which is the context window. And this is the amount of data in tokens. Tokens, you might see, is like a kind of like a word, like the part of a word that you are going to be adding into the text, into the prompt. So the context window is the amount of data that this LLM can consider at once. This will limit the scope of reasoning. So I cannot send a bunch of information to these models. I need to send them by chunks. This is when right now with, for example, Gemini 2.5, people are talking about this model having a million tokens in their context. This means that I can send a million tokens with just one request. So a lot of information that the model can use to make predictions. So the larger the context window, the more accurate or the more data I can send the model so we can do some predictions. There are like two other concepts that are very important. One is the fine tuning and the other one is prompt engineering. So prompting or prompt engineering pretty much is adapt the output using input design. So the better I describe what I want and I ground my prompt and I give context to my prompt, the better output I'm going to get out of the LLM. Fine tuning is customizing the model using new data. We are not training a new model. We are just adding new specific data into this model so it could be smarter at solving certain type of problems. And there is another concept, which is the evaluation. This pretty much takes into account the factuality. Pretty much it is accurate. What it is saying is true. The reasoning, it can kind of like think or reason or do a thought process. And the safety, we make sure that this is out of biases, toxicity, things that might affect the output. So the evaluation is testing these models across multiple axes: correctness, bias, robustness, etc. So we make sure that the model is performing correctly. Cool. Now let's take about the typical type of AI applications patterns that we might find. And this is just the most common ones. There are like many other application patterns, and this is a very fast evolving ecosystem. So we are seeing way more things that are coming every time. So the basic and the most common is the chat. This could be either stateless, a chat that just receives an input and provides an output, or that it is a contextual assistant. The chat is trained on a specific topic and it can help you with that specific topic. Basically, you communicate with this chat. Sending messages is a text-based application. It could be just one turn, a question and an answer, or will be a multi-turn conversation. So it might keep memory of the conversation and you can ask follow-up questions, and the output are just responses that comes from the model. We have the Retrieval-Augmented Generation, or more commonly known as RAG, which is ground responses using external data. So we are augmenting the prompt with external data so we can get a more accurate response. The input is going to be a user query. I will be asking a question. The behavior, it will be retrieving and generating grounded answers, and we are getting LLM outputs. The agent is a multi-step reasoning application that can use tools. An agent pretty much can perform actions on behalf of the user. So the input are going to be specific tasks or goals. It can use tools and perform multi-step reasoning to decide what type of tool is going to use. And the output are going to be LLM actions. We have function calling or tools, which is now just the function calling part of the agent. And basically, this can return a structured output. We can specify our application that instead of responding on a task, you can respond on a JSON object with certain specific structure, or you can respond with code, or you can respond with something that is more predictable. Multimodal applications are applications that involve multiple type of modalities. It could be text to image, image to text. It could involve sound. These are a little bit more complex and requires different types of large language models. Planning and execution, they take a task and break in smaller tasks and perform those tasks. These are also used in agent reasoning. And hybrid, pretty much you can mix and match depending on the use case. Okay, so what type of LLM stack are we going to use for the applications we will build? And for the examples I am going to show you. So first, we need to select a model. What is going to be the LLM we will use for our application? And there are like many options. You can find models provided by OpenAI, like GPT-4o, O1. You can find models by Anthropic, like Claude, by Cohere, which has models for embedding. You have Google with Gemini or Vertex. You have Llama. You have DeepSeek, Mistral. There is a lot of different options out there. They are like proprietary and open source. So it depends of your needs, what LLM are you going to use. Also, for certain applications, specifically for retrieval augmented generation, you might need a vector store or a vector database. And you can use pgvector, which is a extension of PostgreSQL, or you can use products like Weaviate, Pinecone, etc. There is also good to have an orchestration layer that is going to take care of um, these agentic specific actions, how to connect prompts, how to call different LLMs. And we can use LangChain or LangGraph, which are the ones that I'm going to be showing you on this session. But there are many more. You can use the Atlas Reasoning Engine that comes on Agentforce in Salesforce, or you can use Llama Index, which is for a lot of retrieval processes, Crew AI, that are like different products that also give you this agent runtime. Embedding, we will need to use an embedding model for specifically retrieval augmented generation applications. You can use the ones provided by OpenAI, Cohere, or APIs that are available on Hugging Face. And of course, you might need to have a front end. This could be your choice. Build the front end with the technology you want, or you can use something like a Jupyter Notebook or a Streamlit, something that already gives you an interface to interact with your application, with your agents. Or you can build an agent using Slack, for example. There can be like different type of front ends for your applications. And there are like other different components involved in building an AI application that I'm not going to mention. For example, AI proxies, um, all the different tools for LLM ops and ML ops. There are like way more advanced things to consider while building an application, specifically on production. For the purposes of this session, we are going to focus only on the orchestration layer with LangChain. On the data layer with a vector database, we're going to see how to perform tool calling and how to add an interface on top of it. There is something that I wanted to mention here, and it's in regard of tools, which is the Model Context Protocol, or MCP. You might have seen a lot of buzz right now on social networks about this protocol. This was created by Anthropic, but it's now an open standard. So it is pretty much an open source protocol that enables connectivity between AI applications and connect them to data, resources, tools, etc. You can think of MCP as the USB-C for AI applications. You can build an MPC server. This MCP server, exposes tools, resources, prompts, and you can use that MCP server in different applications. It could be, for example, the cloud desktop. It could be on IDEs like Cursor, Windsurf, or it could be on other web applications as well that are connected to an LLM. The client invokes those tools, query for those resources, uses the prompts that are exposed on this MPC server, and this is going pretty much to extend the capabilities that an AI application can perform. A lot of people say, but the MCP is pretty much an API. Yes or no? APIs are different. APIs are not standardized. You can have REST APIs using JSON RPC or using their own schemas. They are like different ways of authentication. MCP tried to standardize all of those inputs and outputs and be able to have a specific protocol so you can connect different applications to use tools and resources. So this is something that is coming right now on the AI ecosystem, and it's getting a lot of attention. And recently, OpenAI also said that is going to adopt the MCP protocol in their agents, which is amazing. But there are like many options, but for building your AI applications, you need to use the right tools for you, the right tools for the problem you want to solve. In my case, well, first I need to design a programming language. This is Node.js Global Summit, so I'm not going to be using Python, of course, but Python is usually the language where you're going to find most of the examples, libraries, frameworks. But since we care about Node.js and JavaScript, we are going to be using that for these projects. And it's another of the languages that are out there that are starting to get a lot of love from the AI ecosystem. And there are like many libraries that you find in Python that are or have its own version in JavaScript as well. LangChain being one of those. And there are more to come. MCP has SDK in JavaScript as well. And there are like Llama Index as well has SDKs in JavaScript. So there is also a great alternative to start building these apps with JavaScript and with Node. Also, we need to pick a large language model. The most popular and common one is the large language model provided by OpenAI, which you might have used with ChatGPT. But there is also other models like the ones offered by Anthropic or Mistral or Gemini. There is a comparison of the same question that I asked to ChatGPT using the model 4.0 and to Cloud 3.7 Sonnet. Pretty much, what are the best frameworks to build agentic AI applications in Node.js? And both decided like the first question, like the first option, it's going to be LangChain JS for the two of them. So we decided to use LangChain JS as our orchestration framework for sure. We are going to also use a vector store. I love PostgreSQL. I've been using PostgreSQL for a while, so I decided to use pgvector for my vector operations. So, what is a vector store? It's a type of database that is designed to store and search for data that is represented as vectors, as an array of numbers. These enable efficient semantic similarity search. So I'm going to be searching for things that are semantically close to each other. How to enable these on a PostgreSQL database? If it has the extension enabled, you just create the vector extension and you can use it as a type on a table to store vector information. So how they work? Pretty much, you store the information as vectors that are going to be multidimensional arrays or multidimensional numbers. Is the text representation into this vector, and where you search for a specific thing is going to return the things that are closest semantically to what you are asking for. In this example query, I am searching on an animal stable. I already embedded all of the different animals in my database, and I'm looking for animals that are similar to a shark. And it's bringing me the animals, not necessarily that are like fish like animals, but also some animals that are related to water as well, like the crocodile, dolphin, turtle, an alligator. So it takes the semantic meaning of the word and it finds for correlations using mathematical operations. We also need an orchestration framework, and as I already mentioned, we are going to be using LangChain. So, what is LangChain? It is a framework for developing, building applications powered by large language models. LangChain has different components, different packages that you can use. The core contains all of the base abstractions that LangChain needs, and something called the LangChain expression language, which is a way to write or chain components that we are going to see an example later. The core LangChain package contains also different chains, agents, and retrieval strategies. There is LangChain community that has a lot of third-party integrations, for example, document loaders, tools, and we are going to use a couple of those in our examples. And there are like partner packages. Pretty much this exposes access to other models. For example, OpenAI, Anthropic, Mistral AI, and you can find also the ones that are for Gemini or Azure, OpenAI, or AWS Bedrock, etc. LangGraph is part of the LangChain company, But this is a more low-level orchestration framework for building controllable agents. This is more to focus on agent applications, and it is for more advanced use cases. This can be used as standalone. It doesn't require LangChain, but integrates pretty well with it. Basically, LangGraph applications are stateful, so they maintain memory across different steps. They have a graph-based flow. Pretty much, they define the control logic as node and edges, and we are going to see a couple of examples that I have that shows how the agent is being processed by following a specific graph. It has concurrent branches. It can perform actions in parallel. It has already retry and fallback logic in the framework, so it handles failures with control flows, and it can perform agent loops. Like pretty much enables the option of thinking, act, observe cycles, which can make an agent smarter. And the package that you will be using in JavaScript is going to be the LangChain LangGraph one. Okay, when to use LangChain and when to use LangGraph? Well, for simple chains and pipeline simple use cases, LangChain.js is going to be the best options. LangGraph.js is going to be too overkill, too complex for this type of use cases. For RAG applications like Retrieval-Augmented Generation, you can use both without any problem. For agent tool, you can use both, but obviously LangGraph is going to give you more control. Specifically on the branching flow, the complex logic, LangGraph already is giving you a graph-based control, but in LangChain, it's hard to manage. You will need to implement your own logic. Stateful agents, LangChain has agents, but they're like pretty limited. LangGraph already have built-in memory per node and per agent. There is no retry or fallback mechanisms in LangChain. You will need to do it manually. LangGraph already have that. And all the concurrency and parallel, it is not supported. You will need to implement it yourself, and LangGraph already have that. So use LangChain for quick LLM integration, simple applications, and LangGraph when your agent needs memory, branching logic, retries. It's some like more for like production complex applications. Now we get into the code. This is a basic completion with LangChain, what I call the basic hello world. Here we are using OpenAI as our partner library, but here the good thing is that you can replace it with Anthropic, Mistral, any other that it's available in the LangChain ecosystem. So first, I am creating an instance of that model. I define the model name that I will use with OpenAI. OpenAI has a multiple set of models. I'm using one of the most basics to just perform auto-completion. I define the temperature parameter, which will define that how similar is going to be the answer every time I ask the same question. And then I just invoke that model with the completion, and it will give me the result. So the basic example is going to have a single prompt. It goes to LLM, and then I get the completion. And we will see this running later when we go to the playground. There is the LangChain expression language, or LCL, which is a declarative way to compose chains together. A chain is just a sequence of operations or steps that link together different components or modules to accomplish a specific task. So, what type of components can we chain together? A prompt. We can compose it with a chat model or with just an LLM. We can compose it with an output parser. How are we going to parse the output of the LLM? We can compose it with a retriever to fetch information, or we can compose it with a tool. And let's take a more complex example. This is kind of like an application that receives two inputs. One is a programming language, and the other input is a problem. In this example, I'm using Python as the programming language, and the problem is reverse a string, and it will return the code that solves that specific problem. How this work? First, I specify a prompt template. This is going to be the template that has the prompt. The system prompt is how I'm going to be grounding the LLM. I am saying first who you are or who the LLM is going to act as, like a professional software developer who knows about a language. So here I am defining a variable in the template. Then how are you going to respond? So return just the code without any explanation and not enclosing markdown. I just need a simple text. And then you can add inline comments if necessary. Then I add the human message, which is the question that I have, the question that the user has, which is generate code for the following use case. And the other variable is the problem. So I'm going to be chaining together that prompt template with the LLM, and then I'm going to pass it to a parser. The prompt template is being piped to LLM, and the parser here is the string output parser, as you can see on line 23. And then I'm going to invoke that chain, passing the two variables, the language and the problem, and I might get a code. Okay, now let's take a look at some of these more complex AI application patterns and go a little bit deep dive on those. And these are going to be part of the playground that I'm going to show later. First one is the chat. So the chat or chatbot is pretty much a stateless, like without memory, or a stateful, a chat that has memory, that knows about previous conversation. This is useful for assistant, support bots, or and usually have a simple UX. I'm just having a conversation with an LLM. And with LangChain, we are using pretty much the same chain that I showed you before. I have a prompt that I'm piping into an LLM, and then I have output parser to get the response. Then I can create an instance of a chat message history. This is a specific class in LangChain that can store the messages or the conversation that I have within the session. And I can extend this message history to store it, for example, on a database like key value store, like Redis, for example. And then I am composing another chain. This time is going to be a chain with history. For this, I'm going to be using some primitives that LangChain has, which are the runables. Here, I'm using the runable with message history. So I am passing the chain, which is going to be the main runable for my operation. Then I'm going to be passing the message history class and the input message key that I'm going to be using to submit the message, and the key that contains the history of the messages. So here I am composing this. I have a single prompt. I go to the LLM and I get a response. This is also a very simple pattern. And you can see on the example, I ask for something and it returns the information depending on the question that I have. And it might have memory of the previous questions that I added to this chat. Another example of an application pattern is the agent. An agent is an LLM application that can maintain memory and make decisions and use tools. So it has some reasoning behind, and it can use the tools that I enable to this agent. For example, in the code that we have on the playground, and we have an agent that has two tools. One is the Wikipedia tool, so it can go to Wikipedia and perform queries. And the other one is the weather tool. It's a custom tool that we can create or that we created using the dynamic tool class in LangChain that pretty much performs an API call to fetch information. Then I create an agent that has access to those tools. And depending of the question that I'm asking, it will decide if using the weather tool, the Wikipedia tool, or the two tools. So it plans depending of the prompt. It selects the tools that will solve the problem that I'm asking to. It executes those tools, and then it can repeat depending of how this agent is set up. So here we have a graph of how this works. It starts, have the agent. If I need tools, I perform the tool call, I get the response, and once I get everything I need, I go to the end. And the other pattern is the retrieval-augmented generation. The source code of the retrieval-augmented generation is a little bit more complex, so it is not on the slide, but we are going to take a look at it in the playground. So basically, first, I need to embed documents. These are going to be text documents into a vector store. For that, I need to use an embedding model. Basically, the embedding model, what it's doing is taking a text, passing that text into a model that converts it into a vector representation, a multi-dimensional array that has the information and semantic information of that text that I pass. Then I store that text into my vector store database so I can perform queries over it. The why I'm doing queries over it to retrieve relevant content based on the question that I'm asking. And then I use the LLM with that content that I retrieve as the context of my prompt to generate an accurate response. So basically, what I'm doing is that I query vectors, I query that information, I retrieve the relevant context so I can ground my prompt. And then now that I have a ground prompt with the content in there, I pass it to the inference model or to the LLM to get that proper response. And we are going to see an example of it in the playground. There are also a way to mix and match different patterns. And here are some examples, but obviously there are like way more. Having a chat with retrieval augmented generation. This is pretty much an smart assistant. It could be an smart assistant for a knowledge database, for example. An agent plus RAG, it could be a context rich research assistant, kind of like similar to a notebook LLM as well, that it can perform operations and fetch information from the web or from the different sources you are providing. Agent plus planning plus APIs, an autonomous task runner. So it can execute tools and external applications through APIs. RAG plus tool use, a data aware agent, agent plus planning, a task executor, chat plus agents plus tools, an AI concierge, a chat that you can use, for example, to book a flight or to do a support case, things like that. Function calling plus planner. You can have also like a DevOps agent that can run your infrastructure, for example. Well, while building AI applications, what do we need to watch for? What are the things that we need to consider? First, latency. When specifically we are using a retrieval augmented generation application, it might take a lot of time performing the query, fetching the context, and passing the context to the LLM. So this is not immediate. Multi-step agents that perform multiple operations and have like complex planning takes time. Also tool use, depending on the tool it's using. There is another latency in there. If it is a local tool or a remote tool, it might take more time to have the answer. There is also the problem of tooling maturity. And that's a specific problem in JavaScript. The JavaScript ecosystem is growing, as I mentioned before. There are like libraries that are catching up uh, with ecosystems like Python. But most of these AI tools or frameworks, SDKs, are being created and released for the Python ecosystem. So there are like certain things that are not there yet, but the JavaScript community is pretty much getting ahead and working to have this maturity. The evaluation complexity, pretty much measuring that factuality, the reasoning capabilities, the safety of a model is not easy to make sure that the model we are using, it is not biased or it is not toxic. That requires a lot of work. The model limits, we are going to be limited by the context window depending on the model we are using. And also if we increase that context or we perform multiple calls, this is going to be more expensive. And also another problem that we have is hallucinations. Hallucinations is where pretty much the LLM is coming up with its own answer that it is not correct. It's just guessing or inventing things on the fly. And the more accurate and the more descriptive the prompt and the more context we pass to the LLM, the better response we are going to get. But we are not free of having hallucinations. And this is a fast moving ecosystem. Every week, there is something new coming on, a new model, a new framework, a new technique, a new protocol. So catching up, it's a little bit difficult, but to be able to use all of these things in production, there is a risk also. Stability and long-term support can be uncertain. But if you are, eager to catch up and study and get also in the latest, greatest things that are happening, this is also a very exciting time to be investing in AI. And some takeaways before we go to the demo. Node.js is ready. Even though the ecosystem is not mature enough, LangChain and LangGraph enable for you a way to build full agentic AI applications. There is a company behind betting on these libraries and supporting them, even though they are open source. LangChain also has like some commercial products behind, so they need this to succeed. But there are also another options that you can use within the Node.js ecosystem to build this type of applications. Another thing is, depending on the use case, you need to pick the right pattern. Are you building a chat application? Do you need to have agents? Do you need to mix and match? Depending on what you want to build. Please go ahead and combine the different tools that you have available. The different models with memory, with these orchestration layers, you can create wonderful applications. And make sure you build those on a composable and modular way. So you can swap a model. Maybe today, OpenAI 4.0 is the one that you use, but tomorrow you're going to find that Claude is going to be the model that it's going to solve your problem better. So build these solutions on a way that you can easily replace the model or replace the data store, so you don't need to be vendor locked in. And last but not least, as the creator of JavaScript said, Brendan Eich, always bet on JS. Well, let's go to the playground. I already gave you the URL. You can go to this URL to take a look at the source code and the demo. You can play with the demo as well. So now let me go. This is the application. If you click on learning resources, you are going to get a list of links so you can learn more. But these are the examples that I wanted to show you. First, the hello world, the basic completion. You can pass a text and it will try to complete. For example, never gonna give. And it will obviously autocomplete, never gonna give you up, never gonna let you down, never gonna run around and desert you. And this is the example. Basically, exactly this code is the one that I'm executing here. Another example is a structure output. So here I'm using a popular library called Zod to create a schema. Here I am describing how I want the LLM to respond. I want to respond with an object that has a title, a description, an array of ingredients, and an array of steps. This is for a recipe application. Then I said that object into my model, and I am specifying that I want a structure output, and then I am executing. I'm going to pass the messages with the prompt, the question that I'm asking, and then I get the response. So how this work? I pass a list of ingredients and it will give me a JSON so I can always know the shape of the object the LLM is going to respond so I can add it to my interface. Let's say I have ham, eggs, cheese, and tomatoes. And the recipe that is going to create is a ham and cheese omelette. It is giving me the description, the list of ingredients, and the steps to build my recipe, which is exactly the prompt that I ask here. And it's always going to reply with that JSON. Okay, an example of the LangChain expression language. We are composing here the prompt template with the model, with the parser. And this is the example that I show you with the code. Pretty much, let's say, in JavaScript, do a fetch website using native libraries. And how to generate the code is going to give me the code. This is how I will give you the response. If I change this to Elixir, now it's going to return with the Elixir code that performs that HTTP operation. The other example is the chat. Here now I have a chat that has message history support. So this is the full example with all of the code. When I am creating the chain with history, I am passing the chat message history class. This is how I invoking it, and I am setting up a session ID in case I need to store this memory in a database and I can retrieve it every time I'm going to start a conversation. This could be a user ID or something like that, or depending on the conversation that you created on your application. And this example pretty much takes a skill that the LLM knows. So you are an assistant who is good at certain skill, and it will receive a message. So you are good at Node.js. I need help with my code. So I send the message. Of course, I'm happy to help. How to perform an HTTP request with Node. And it's giving me the response. And what is my problem? I'm asking about my problem and it should know because I have memory. Okay, it failed here. What I asked before, let me see if it works. Okay, now it knows that I was asking about the HTTP request. So this is telling me that the chat has memory. Now let's go to agents. This is the example where we can go to the Wikipedia and we can execute the dynamic tool. Pretty much my dynamic tool is getting the weather from the Open Weather API. And let's see, what is the current weather in Tampa? Is where I am located right now. It's giving me the weather and tell me a random fact from Wikipedia about Tampa. So now it is going to use the other tool. So the current weather, and then there is a random fact about Tampa from Wikipedia. Fantastic. You can find another examples here, like the Retrieval-Augmented Generation, where I'm storing repositories into a vector database, so I can ask questions to it. For example, I can ask, what is this project about? And it will check all of the different documents that are stored in the database and get the question. For this, I am loading the documents using the GitHub repo loader from the LangChain community. Then I'm splitting those documents into chunks. So every time I do a search, I just submit certain specific parts of the document. I don't need to send everything. And storing those in the vector database. Then for the question, I need to do the retrieval process. Quickly, we can take a look here, now that we are running out of time. For the question, I set up the two chains. One chain is the one that is going to combine the documents with the prompt and then LLM. And the other chain is the one that is going to be doing the retrieval. And then I ask the question. We didn't touch this into our session, some examples, but here I'm also adding some lang graph examples. This one is to show how to create a React agent, not React the front end framework, but a React type of agent, reasoning and act. And this one can use tools, and the tool we are using here is the web browser tool, so it can go and fetch pages from the internet. The multi-agent one, here we are setting up a complex flow using the graph. So this has a fetch weather agent, then it will execute in parallel both analyze weather and suggest events if there is weather information. If not, we are going to finalize the flow. For that, we are using a conditional edge. So let's say if we pass here a city, let's say Tokyo, it is failing to fetch the data weather from Tokyo, but if we execute for Tampa, it is failing. Let me try to execute again. Now we get the response, so maybe we are getting some rate limit issues, or since I'm using the free API, I'm not getting the proper responses. But now it works. Here we can see that it's getting the weather information and it's doing the analysis like we defined in the graph. And last but not least, this is how we can use MCP with LangChain. So here we have an MCP server that can go to a PostgreSQL database. In this case, I'm using my own PostgreSQL database where I am storing the repositories. I connect that with my agent, and my agent can now call those tools. In that case, perform queries to my database. So show all the repositories and how many embeddings do we have in repo embeddings. So this is going to perform a query in the database, and we can see the first repository, the second repository, and the number of embeddings that we have stored in the database. Langsmith is a very interesting tool that you can use to debug LLM operations with LangChain. And here we can see all of the different calls that we perform to our LLM, and it's telling us the input, if there is an error, what was the latency, and the number of tokens and the cost of that operation. And from the very basic, which is the autocomplete, to the last one, which is the MCP call. Here we see the different query that it performed on the first operation and on the second operation. By using the MCP, this is performing the multiple tool executions. The one that is using the different agents, the fetch weather, analyze weather, and suggest events, or the one that is doing the retrieval-augmented generation, so we can see the query that it's performing to the database, the different documents they are like returning, and how it is adding those documents to the prompt template. And this is the prompt that we are going to send to OpenAI and then get the response and pass it to the parser. Very awesome tool that will help you debug and log your LLM calls with LangChain. And you have examples, you can run them yourselves. You can deploy this application also to Heroku and give it a try. You will need to have like certain API keys to be able to perform all of the operations. And that's it for it. Thank you very much and see you in the next one. Bye bye.